Good morning and welcome to another PolyWorks webinar. In today's webinar, we're going to look at a tool in PolyWorks which is called statistical process control. And more specifically, we're going to look at the surface data SPC. So you do have two types. You have the statistical process control for objects, and you also have the surface data SPC as well. So what we've been doing the last few weeks here at 3D Scanners is we've been scanning some Easter eggs. You may recognize the branding of the Easter egg that we've been scanning. We would like to remain impartial though, and would recommend that there are other Easter egg brands out there for you to purchase. Now, as we go through today's webinar, those of you that have watched before will know that we have a text chat functionality available. If you do have any questions, please feel free to put the questions in the chat, and one of our operators will be happy to answer your question. Now, if you're watching this later in time, please feel free to contact us on any of our social medias, 3D Scanners UK, or you can email support@3dscanners.co.uk. So, beginning the webinar, we're going to start, as I said, we're going to look at some surface data SPC. So, there's two different examples I'm going to show you in today's webinar. The first one involves using the new piece functionality within Inspector. So just to show you, I have created 3 pieces, and you may recognize some of the names of the eggs that I've scanned previously. So what we've done is we've created a small piece of CAD, which you'll see is shaped like an Easter egg. So I'll show you that. So that's our Easter egg CAD. And we've aligned each of our scans to the egg. Okay. So we're going to jump into the drop down here for our SPC, and we're going to jump into the surface data statistical process control. So what you'll see here is we're now going to look at initializing our surface data SPC. So we have different techniques, as I mentioned previously. So the first one we're going to look at is this one here, which is called from project. So as I mentioned, we've got 3 different pieces in this project, and we're going to look at comparing the scans of these eggs. Okay. One of the criteria with the SPC, especially the surface one, sorry, is that you need to have what's called a reference object. So we have our CAD model. That in this particular example will act as our reference object. Because essentially the way that this surface data SPC is going to work, if you're familiar with comparison points, they are very similar. So what's going to happen is a sort of sample grid will be projected onto the CAD surface, and that will act as our surface data SPC. So we have some options here that you may be familiar with if you've used comparison points. So we have the sampling step, which is the distance the points are apart from each other, and we also have the max distance as well. Now that's how far away from the CAD model PolyWorks will search in order to find a data object. In the More tab down here, we can do a few other things as well, which are quite common with comparison points. So you have your measurement point radius, your measurement type, and some different filtering options as well. And what I'm going to do is I'm going to hit initialize, so you'll see the surface data SPC begin to work. So you will see here that we have created a color map. So you'll see here that the color map is projected onto the actual CAD model. So what I can do is hide the data out the way, and you'll see we have a color map here, which has been projected onto the CAD. Down the bottom here in our surface data SPC window, you will see that we have our 3 pieces in there already. The dates, obviously when they were inspected as well. And also we now have some different options here. So you'll see, I will come back to this one here for the display, but you will see we now have a color map option which we're allowed to change to many different ones. So currently we're set to the average deviation. So what this has done is PolyWorks has calculated the average deviation of those 3 pieces that we have. So our 3 different egg scans, and created a color map based on that. We have some other options available. So for example, we have the highest deviation, which I will flick to, so not much change there in that example. And then I will flick down to the lowest deviation, and we also have the option of the largest deviation as well. So that will show us where the largest deviation is on our pieces. What we can do as well is we can toggle these on and off. So I can turn off piece number 3, which just happened to be the twirl Easter egg. So I can turn that on and off just to see the difference that makes. Or another thing that I can do is you'll see here in the display drop down, instead of looking at the whole SPC, what I can do is look at an individual piece. So if I flick to the individual piece itself, you see here that I'm able to quickly flick between our different pieces. And what this will also do as well is if I just flick to, for example, the heroes piece, this is actually a solitary colour map for that one piece. So you'll notice that in the tree view, I don't actually have a colour map created. So one of our sort of nominal colour maps here, so data object deviations from reference object surfaces, that would be the typical way you would do it for sort of one scan compared to CAD. Whereas when you use the surface data SPC, you will see that you can quickly just flick between the different pieces and it will provide a colour map based upon that piece that you've got selected here. What I can do though is jump back to SPC, and what I can actually do is similar to a standard colour map, we have the option here to create a colour map point annotation. And what this will allow me to do is similar to your normal ones, as that's what it is. I can left mouse click and create a point on the CAD model there. And what this will do is it will show you where that point lies within the reference object's tolerances. So you'll see here we have our upper specification limit and our lower specification limit here as well, and also the 0 as well. Now, for those of you that aren't familiar, that is controlled in your reference objects icon across your main objects toolbar, and then in here as well. So we have edit reference primitive tolerances. So that's the icon where you can go and change the tolerance for your CAD surface. So what I can do is if I hover over the top of one of these points, you will see here that it will tell you which piece that is and the deviation at that specific point there as well. So again, you've got a few other options in there. So I'll just put a few on there as well, just to show you a few different ones. And then obviously the first one is now hidden. So what we can do is we can use our annotations button and position them so we can see the rest here. Now, as I mentioned, this particular technique uses the new piece functionality. Just to show you again, we only currently have 3 pieces in here at the minute. What I can do though is I can add a fourth piece. So what I can do is I can use the new piece functionality. Of course, it will ask me to save it first. What I can do is rename this. So I know for a fact we're going to be using the orange twirl for this one. So I'll call that twirl orange. And our launch play inspection won't go through too much as it's just importing, and an automatic best fit will be performed in the background. So you'll now see that we now have the twirl orange piece. That's the 4th and final of our pieces. But what you may notice down here is that currently it's not been measured, and you'll also see down here as well on the 3D scene that our annotations have not yet updated. What we need to do is, as I've done here, is highlight the new piece and then come over to the right hand side and hit measure. And as you'll now see, we have the green tick to indicate that's been measured, and we also have the point allocated to our annotation as well. So just to finish off, a few things that we can do is we can report this. So what I can do is hit on the report icon down here, and what we can do is we can look at, for example, values per piece from annotations. And what that will do, look, is depending on your report settings, whether it's set to active formatted report or to come straight to the tree view, I can jump into report 1 and you'll see here that I have a table created. So what this will do, look, is unfortunately with colour map annotations, you can't give them names. So you'll see that they're labelled based upon the XYZ position of where I've anchored them. So you'll see here that we have the position of the 3 surface point annotations and also the deviation value as well. So I'm now going to show you the second technique that you can use for the Surface Data SPC tool. Now, I've opened up a different project and you will see in this particular project, my 4 scans are all in the same project. So you'll see they all have their own alignment group, but there are 4 of them in here. So I have taken the time beforehand to align these together. Now, if they were for example, in a checking fixture, you would hope they are aligned beforehand anyway. So you can see that they are all overlapping. So there are different techniques in order to achieve this as well. But similar, so what we did before is we looked at how you could compare against different pieces. I'm now going to show you the second technique, which is how you can do it as different data objects instead. So I'm going to again jump into our surface data SPC. And this time you'll see we're going to use the second option in the drop-down list, which is called from data objects. Now, as I mentioned in the previous video, you will see that we need a reference object in order to do this. So I currently do not have a reference object available. Now, you may not always be fortunate to have a CAD model to hand, or indeed a reference object. For example, if you're looking to reverse engineer something, or trying to find a master sample. So we can actually get away without one. So I'll show you how you can get around this. So I'm going to hit cancel, and I'll just close that down for the time being. What we can do is we can actually convert one of our data objects to a reference object. Now, what I'm going to do is, the last one that we have here is the twirl egg. So I'm going to right click first of all, and go to create, and then create duplicate. That means I can still use my original scan, and I'm going to convert the duplicate to a reference instead. Now, in order to do this, I can right click on the duplicate, and I can go down to edit, and I can click on this option here, which says convert to reference object. So you will now see in our tree view, I now have a reference object available for us to use. So jumping back into Surface Data SPC, you will now see that we have the reference object available, which again is the duplicate. Same options as before. So again, all to do with the reference object, similar to a comparison point. I'm going to hit initialize. Only this time, the difference here is you will see that nothing actually populates in the window at the bottom. So what I need to do is I need to highlight my 4 data objects. And then on the right hand side of our Surface Data SPC window, I can click this button here, which says add pieces from data objects. So I can do that, and you will now see, look, that we have, again, our color map here. So similar to before, we can either use SPC or the individual piece. And again, we have the same options here. Now, these will refer back to the reference object we've created. So this does depend on the one that you've chosen here. So what I can do is, again, I can use the color map annotations and create that for us there. So same principle as before, exactly the same. To finish off, I'm just going to show you one of the tables that you can create. So in here we have report, and then if I choose the pieces option, so same as before, if your report items are set up to go straight into the report, the formatted report, I can double click, and I'm just going to drag this down so you can see the table that's been created. Now it will give you all of this information you can see here. So it will give you the 4 pieces and the standard deviation globally. One thing to note here, probably the most relevant piece of information here is if you're looking to, for example, create a master sample or one of your parts that doesn't have CAD, if you would like to use that as your reference moving forward. In the table at the top here, you have what's called the median piece. Now, the median piece is the one which is closest to the average of all the scans. So you'll see in our case, it's the twirl orange. So that one of the 4 scans is the one that is closest to the average. That may mean you want to use that one going forward to do any inspection from, or in fact, use that as your reverse engineering object. The final thing you may possibly like to do, if I close this down, is now that we have our 4 scans, what I could do is you might want to create the average STL. So you might want to create the average data object from those 4. So what I can do is jump into the tools menu, go to data objects, and then this option here is called create data objects from Surface Data SPC. So if I jump into here, you will see I can name it accordingly to depending on what I would like to call it. And I can create it from the following options. I can create average deviations, highest deviations, or lowest deviations. So what I will do in this instance is I'll leave it on average and hit create, and that will quickly create an average STL. So if I hit close, you will see here we have data 1 average just there like that. So I could then potentially export that, right click and say export as polygonal model and use that for future projects. That brings us to the end of today's webinar. As usual, please provide any suggestions for future webinars. You can contact us again through support@3dscanners.co.uk, or you can find us on any of our social media platforms if you search 3D Scanners UK. Again, thank you today for watching. We at 3D Scanners would all like to wish you a happy Easter and look forward to seeing you on the next webinar. Thank you.